This is what we'll be making in this video. I got the idea from a guy named Matthew Wallach. I think that's how you say his name. I saw this shot in his demo reel and I thought it would be really cool to try to recreate it using geometry nodes. The project file is available on Gumroad for $1 and it's free to all my patrons. It includes everything we'll cover in this tutorial, plus it's set up so all the controls are in one convenient spot. The money stack model is available for free so that you can follow along with the tutorial. Links to everything I've mentioned, including Matthew's demo reel, the money model, and the project file can all be found in the description. Start by either modeling a stack of money or downloading it from my Gumroad profile. For reference, if you decide to make your own, the dimensions are 0.15596 meters wide, 0.06629 meters deep, and 0.022 meters tall. That'll make a stack of money $200 bills thick. For shading, I'm using an RGB node plugged right into the shader, and I'm just assigning it to the faces directly. The colors I'm using are 6D7F64 for the green, and F0BC93 for the peach color. Click the default cube and rename it to grid. Click on the Geometry Nodes tab. Click New and create a new Geometry Node setup. Press Shift A and then add in a mesh primitive grid. Place it in between the group input and output. Delete the group input connection with Control right mouse button drag. Connect vertices X and Y to the group input. And finally rename them to width and depth. Before we continue with this setup, let's start the next setup so we can visualize what this one is doing. Add in another Geometry Nodes modifier, add a point instance and place it between the groups, and use the money stack as the object. Now, back in our first setup, we want the money stacks to be spaced so they butt up right next to each other. Let's just work on one axis for now. Add a math node and set the operation to multiply. Use the width input for one of the values and the width dimension of our money stack, which if you remember is 0.15596 for the other value, and connect its output to size X. You'll notice it kind of works, but at smaller values there are these big gaps. To understand why, disconnect the width input. Now width is controlling the size of the grid by multiples of the width dimension of the money stack. If we set it to 4 and play with the number of vertices, you'll notice to make it right, it needs to be off by 1. So if the vertices are in, then the width needs to be n minus 1 for everything to work smoothly. So to get them to always match, we have to add another math node before the multiply node and set it to subtract 1 and reconnect the width to vertices X. Now they're working fine, but I'd like a gap between them that we can adjust. Let's create a new vector input by adding a separate XYZ node and connecting it to the group input. Go ahead and rename it to gap and set its min to 0. If I connect the X output directly to the multiply node, I'll have to set it to the width dimension of the money stack in order to have no gap. But I want it so that 0 is no gap and anything extra is added on. To do that, let's add another math node and place it between the separate XYZ and our multiplication node and set the value of our width dimension, which again is 0.15596. Now 0 means no gap, just like we wanted. We can repeat this same node setup for the Y dimension. Just select the 3 math nodes and duplicate them by pressing Shift D. Connect the multiply node to size Y. Connect depth to the first input on the subtract math node. And finally connect the Y output on the separate XYZ node to the first input on the add math node, and then change the value to 0.06629. At this point we can increase the width and depth of the grid, as well as add a gap between them. I'll set my grid dimensions to 10 by 20 and my gap to ½ an inch, which is 0.0127 meters. Next, we want this 2D grid to be a 3D grid, so let's add an array modifier and put it between the 2 geometry nodes. I'll set its count to 1 for now. We'll increase it later. Disable relative offset, enable constant offset, Set the X distance to 0, and set the Z to the height of our money stack, which is 0.022. Now that we have this, let's start working on the top grid that we will use to delete certain areas of the grid. Let's start by copying and pasting the grid. Don't use Shift-D here, or else you'll run into some linking trouble down the line. Delete the other money stack it creates, rename it to delete grid, and delete the last geometry node modifier, since this isn't going to instance anything. Let's hide the grid so we can see what we're doing. Now that we have a grid, we want to make it have hills and valleys that we can control. So let's create a texture that we will use to drive the Z position of all the points on our grid. Click Create a new texture, set its type to clouds, and increase the size to 2. Then back in geometry nodes, let's add an attribute sample texture, put it after the grid, and use the texture we just created. Mapping will be UV_map from the drop-down menu. The result can be anything, but I'll choose POS for position. Now we need to split position and the actual position. Do some funky math stuff in between and combine them back together. So let's split out the POS first using an attribute separate XYZ. The vector will be POS, and we only need the Z. Let's label it POS_Z. Then let's do the same to the actual position attribute, but this time we only need the X and Y. Add in another attribute separate XYZ. Use position as the vector, and POS_X for the X, and POS_Y for the Y. Now that we have the X, Y, and Z, let's combine them with an attribute combine XYZ. Change all of these floats to attributes. Use all the attributes we just created. And for the result, use the position attribute. Alright, now we're getting somewhere. At this point, it would be tempting to use the contrast slider to increase the amplitude, but that maxes out at 5 and can't be overridden. To increase it properly, add an attribute math node after where we created POS_Z. Set the drop-down menu to multiply, and change the B input type to be a float. A will be POS_Z, and the result will be POS_Z. And now we can use B to increase the amplitude. After you had fun poking around, connect the B socket to the group input and rename it to amplitude. Now we can control the amplitude without limits. If we increase our amplitude a lot, you'll notice that it keeps going further and further away from the origin. That's because the values from the cloud texture go between 0 and 1. If we subtract 0.5, they'll stay in place better. So let's do that by adding an attribute math node before the multiplication and subtract 0.5 from the POS_Z. Now when we increase the amplitude a lot, it doesn't go flying off in one direction. I think we should be able to adjust the height. So let's add in our final attribute math node. Place it after multiplication. Set B to float. A will be POS_Z, and the result will be the same. Now we can move it up and down using this input. And connect the B from our add node and rename it to height offset. Let's work on making it so we can slide and rotate the texture around. Right now it's static and we can't really change it. We can only move it up and down and amplify it. To fix that, we're going to need to manipulate the UV map before it's written to the POS attribute. So grab an attribute vector math and insert it before the sample texture. B should be a vector. A and result will both be the UV map. And B will be connected to the group input. Rename it to texture offset. Now when we move the offset X, Y, or Z, it slides the texture around. However, if we want it to loop perfectly, we can't do that with translation, since translations never repeat, but we can do that with rotations. To rotate the UV map, duplicate the attribute vector math node and place it anywhere between the grid and the sample texture. Then add in a vector rotate and connect the output vector to B. The type of rotation is up to you. However you decide, just be sure to connect all the inputs except the vector to the group input so it can be controlled easily. Then, as long as the center is not 0, we can play around with the angle or rotation and it'll loop every 360 degrees. The bigger the center values are, the more movement you'll get, so you can think of them as speed controllers. That's all for the delete grid. Now let's finish up the grid so it interacts with the delete grid. Make sure you're on the last geometry nodes modifier. And start by adding an attribute proximity node before the point instance node. The type will be points. The target will be the delete grid. We can bring it into the node setup quickly by dragging it over like this. Then connect its geometry to target. We'll call the distance attribute dist. Leave the position blank. Next, we'll use the dist attribute to scale the money stacks. So let's add in a point node scale between proximity and point instance and set the type to attribute and the factor to dist. It may be difficult to tell, but now they're shrinking, although it's very gradual. If we play around with the delete grid, you can see what I mean. The closer it is, the smaller they get. However, we want them to be either 100% or 0 with no in between. That sounds like a floor function to me, so let's add an attribute math node after proximity and set it to floor. And both of these fields should be set to dist. You might have to move the delete grid up a bit to see the effect. Now that we have them disappearing, it would be nice to be able to control what range they need to be in before they disappear. So let's add in our final node, which will be an attribute map range node. It needs to come before the floor is calculated. The attribute field should be set to dist, and so should the result. From max is the input that handles the influence, so connect it to the group input and rename it to influence. And finally, turn clamping on so it doesn't keep getting bigger and bigger. For such a small scene, I'll set the influence to 0.125. At this point, we're mostly done. If you want to take this a step further, you can add all the controls onto the grid so they're all in one spot using drivers. That's how I have it set up in the project file. If you're enjoying this video, consider giving me a thumbs up and subscribing to my channel. I make in-depth tutorials like this every week and I think you'll learn a lot from them. To do a quick animation, let's go to the Animation tab. Then in Preferences, click on Animation. Then under F-Curves, set the default interpolation to linear. Now play around with the grid and the grid delete until you have something that looks nice. My settings on the grid are 10 for the width, 20 for the depth, 0.0127 for the X and Y gap. On the array, I've set it to 40. On the grid delete, the width, depth, and gap all need to match the grid. Set the amplitude to 1. Set the height offset to 0.5. Zero out all the texture offsets. 0.1 for the X center. For the X axis, I'll set it to 1. And 0 for the angle. And on the array, I'll set its count to 40. The delete grid geometry is just calculating when the money stacks should be hidden. It shouldn't be rendered, so disable it in the view and renderer. There's a bug in Blender that makes animating a little tricky. If you try to animate with keyframes, the geometry nodes won't update each frame, so the render will just be the same frame over and over. However, there's a workaround using drivers. First, decide how many frames you want the animation to be, and set your end time to that. I'll set mine to 100. Then in the angle field, type hashtag open parentheses 2 times pi times frame close parentheses divided by 101. And you also need a driver on the array even though it won't be doing anything. Just add a driver, delete the variable, and set the expression to whatever value you choose. I'll choose 40 in this case. Now when we play, it loops perfectly. Before we render it, let's set up our camera. To make moving the camera easier, let's enable camera to view. You can do this by pressing 0 on the numpad while your cursor is over the 3D viewport, then press N, select the View tab, and check Camera to View. I'll press N again to hide the N panel. Now let's get a nice angle. Under the camera properties, we can set the type to orthographic. This will give us an isometric look. In the object properties, I'll set the rotation for the Z-axis to be -45, 0 on the Y, and 54.7356 on the X. Or this number. That'll give us a true isometric view. I advise locking the rotation so you don't accidentally rotate it, then play around with the location until it's good. To zoom in or out, go back to the camera properties and adjust the orthographic scale. On the World tab, set the background color to FE9050 or whatever you think looks nice. There are no mistakes here. Then to export it, come over to the Printer tab, set your resolution to whatever you like. Pro tip, set the percentage to something small like 25 until you get the speed and movement just right, then render it at 100% when you think it's good. This is especially true if your computer is slow and it's not playing back in real time. Under Output, select a folder where it'll be stored, then under File Format, change PNG to FFmpeg Video. Under Encoding, change the container to MPEG-4 and set the output quality to perceptually lossless. Then press Ctrl F12 to render the animation. When it's done, you'll have a video like this. I encourage you to play around with all the settings and see what you can come up with. Try swapping out the model for something else or use different textures. If you come up with something cool, my social media links are in the description. I'd love to see what you make. I'll showcase them at the end of the next video if I get any takers. If you don't want me to showcase them, just let me know. Well guys, that's it for this video. Thank you so much for watching. I hope you've learned something from this video. Have a good one and take care.